Today we're going to talk about 7-4, applying properties of similar triangles. Let's start off with some math humor. What do you call two L's? A parallel! A pair, L's. Oh man, that's good. So we have a few different properties to talk about. The first is what we have, the Triangle Proportionality Theorem. We're going to come up with it, almost show you where this comes from. And let's just start with a triangle. It doesn't matter what kind of triangle. I'm going to call this triangle ABC. You can call yours whatever you want at all. Now, where do we go with this? Let's just choose a side. I'm going to choose BC. I'm just going to choose the bottom one. Now, what we want to do is we're going to draw a line that goes through this triangle somewhere, but it's parallel to BC. So let's see if I can do this freehand. That looks pretty good. Now I said it's parallel, so make sure you put your parallel signs in here. I'm going to go ahead and label these intersection points. So let's call this X and let's call this Y. So now we have, if you notice, we have two triangles. We have triangle ABC, the big guy, and AXY, the little guy there. Now, what we could do is that, well, now we know this is almost just like section 7-3, coming up with why these triangles might be similar, why the little triangle is similar to the big triangle. Well, we could use you can use angle. I say angle because we have this little angle X right here, AXY. This angle is congruent to angle B. Y, it's corresponding angles. Same with this AYX and angle C, they're corresponding. So we could use angle to say that triangle ABC is similar to triangle AXY. Now, once we know that these two triangles are similar, we can set up proportions about the side lengths. So I could say the little side length, AX, over the big side length on the left side, which is AB, will be equal to AY over AC. Now this here, what we just did, is exactly what the Triangle Proportionality Theorem says. So that's kind of a disclaimer. All it does is that it skips this step right there. It skips we could use angle to say that the triangles are similar. All it's going to tell us is that if we have a line that's parallel, then we can jump straight to saying this. But the reason why is because of similar triangles. So we talked about that Triangle Proportionality Theorem. We kind of said where it comes from. What exactly is it? Well, it says that if a line is parallel to a side of a triangle, as we talked about, and it intersects the other two sides, then it divides those sides proportionally. So we can jump straight into an example here. What we're going to do is find the length of PN, find the distance of PN. We see PN is right here. Now we have these triangles. We have the big LMN, and we have the little PQN. Now it'd be difficult to find out what PN is, except we have this theorem here. It says that if we have a line parallel, well, hey, we have a side of the triangle, which is LM, and we have a side parallel. We have PQ, which is parallel. So we can use this theorem immediately, and let's go ahead and write that down. We can say since, this is just for your notes, so you have this down. Since PQ is parallel to segment LM, we can use theorem 7-4-1. And this tells us that it divides the sides proportionally. So we can set up a proportion about these, dealing with the left side and the right side. Set up the proportion of LP over PN, because it's dividing the side up, which is equal to MQ over QN. And now just start plugging in some values. This is the same as well. We know LP is 3. We don't know what PN is. And MQ is 2 over 5. We know how to solve this, and it's cross multiply. I'm going to go ahead and cross multiply up here just for some space. We see we have 2pn is equal to 15. Therefore, divide by 2. And we see that we have pn is equal to 15 over 2, or 7.5. Now we found the distance of pn, and we are done because that's all we wanted to do. So our distance is 7.5. We'll talk about one more theorem in this video, and it's theorem 7-4-2, which is the converse of that theorem we just talked about. Remember what converse means? It's the exact opposite. It means that the hypothesis and the conclusion are flipped. So we start with, if a line divides two sides of a triangle proportionally, remember this is what our conclusion was before, well then now we know that that line is parallel. This is what the theorem tells us. Let's go ahead and jump straight into an example here. We know the distance of AC is 36, the distance of BC is 27, so we want to verify that segment DE is parallel to segment AB. So we have this triangle here. We know that AC, let's go ahead and write that in. AC, the whole length is 36, and BC, the whole length is 27. Verify that DE is parallel to AB. Now, we can use this theorem here. We're going to try to, because a line divides two sides of a triangle. Well, it does, so we need to see if it does it proportionally, meaning we need to see if this ratio of DC over AD is equal to the ratio of EC over BE. That's what we hope. Again, we hope that DC over AD, and I'll tell you that this is what we want. We want DC over AD to be equal to EC over BE. So let's see, what is DC? DC is 20. AD is, careful here, it is not 20 and it's not 36. AD is right here. Well, if AD plus 20 is 36, then we must know that this is 16. Now again, we want this to be equal to EC and BE. What is EC? EC is 15. And BE, for the same reason, is going to be 27 minus 15, or in other words, 12. Now right now, we don't actually know if these are equal. I'm going to put this question sign here because we don't know if they're equal. Let's try to reduce them. What is 20 over 16 reduced to? Well, it reduces to 5 over 4. And the second one, let's see, we can divide both of them by 3 to be 5 over 4. Well, hey, look at that. These two ratios are equal, meaning that the sides are proportional. And so since the sides, and what I'm writing here is the sides are proportionally divided, then we can use this theorem. Then we say that theorem 7-4-2. I ran out of space there, but basically we saw that this is our work that we showed. We showed that, well, hey, they are proportional. So therefore, theorem 7-4-2 says that it has to be parallel. Anyway, these are our two theorems. One of them is the triangle proportionality theorem. The second is the converse. They're exact opposites of each other, but they're fairly straightforward. Go ahead and write down any questions you have, and we'll talk about them in class.